So hello, I'm Arha. I'm a sophomore majoring in mathematics and computer science at the University of Illinois, Urbana-Champaign. So over the summer, I interned at NCSA under my mentor, Dr. Doug Friedel. So for part of that, I had to familiarize myself with Parsl and the code base. So I did that by tackling some GitHub issues. I'm going to talk about one that I found kind of interesting. So if you look at this code here, this is kind of a replication of the sort of bug I found. So this is a typical Python app, and there are two different function calls for it. So we might expect that they have the same behavior or perhaps different behavior. So if we think about normal Python, these two function calls should have the same identical result. This is because in the second call, the positional argument just gets bound to the keyword argument, and so it's effectively the same thing. But if we run this with this Parsl decorator and all that, we get something that says like type error, wait, we got multiple values for the argument wall time. So this essentially means we're getting two separate values for the same argument wall time. But why is this really happening? So to do that, I had to kind of look into how Parsl really works to sort of parallelize our functions. So Parsl does this using the Pythonic construct of decorators, but that's not exactly quite right, because if you look at the source code on the right, you can see that Parsl is really giving us an object, but it still defines a decorator function, which gives us the syntax sugar, but there's still some internal processing that goes on with the creation of the object. And of course, we still interact with it like a function. Now, to get that behavior in C++, you might overload the call operator, but what's happening here in Python is that there's a special class method defined. It's like underscore underscore call underscore underscore, and that does the same thing. But the thing is that this function signature is basically, it's fixed, right? This is already created under the Python app class. But the problem is, how is it going to know that at runtime, right? Because you can't just magically change that to match all those named arguments that you're passing in with your arbitrary function. So what happens here is that it just takes in var args and keyword args in Python. So you might have also noticed that I specifically chose a parameter called wall time. So Parsl has certain special parameters that have some extra behavior associated with them. And there's some introspection that Parsl does to handle these differently than normal parameters. So that introspection is part of why Parsl returns a class, because this class, the constructor inside of it, it basically looks through the list of parameters in the signature, and then if it finds the special ones, it'll register them in some way. So you might be thinking, is that really necessary? Why do we need to do this in Parsl? Well, it's because these special parameters usually come with default values, right? And then these default values will only get reconciled when you call the original function. But inside the call function in Python app, what's happening is this is just a call to the data flow kernel, and then that passes the function and parameters along, but it doesn't call the original function. So we don't have these default values associated with anything yet. So inside data flow kernel, there's different behavior that's going to change according to these special parameters. So we need to know what these values are. So you need to like have this introspection and find the default values and put them in already. But then where's the actual bug? So this happens because the internal processing to support these default values, it stores a dictionary of the default arguments for these special keywords. And now this is updated in keyword arguments, and that's keyword args is passed into the data flow kernel in some sense so that it has access to it. But the problem is that if the parameters are not passed in explicitly as a keyword argument, it gets thrown in with regular args instead. So then the keyword argument dictionary is updated with the default values, and then you also have it in args. So then when the function is called, you get it twice. So the parameter is bound to whatever is passed into args, but then it also sees that you're specifying it in keyword args, and that's where you get the sort of double definition of a parameter. And that's some interesting behavior. So now the question is, how do we really fix this? it's kind of fixable if you do binding of the parameters earlier in the process. There's something called inspect.signature.bind that allows you to take a bunch of parameters and bind it to a particular function signature. So it associates the parameters with the arguments.
I
But
mean, that's
this still requires some refactoring of how Parsl handles these special keyword arguments, because Parsl internally in the data flow kernel still expects it in the keyword arguments dictionary. But the thing is, if you look at the actual standard, a bind actually considers only explicitly like variable keyword arguments as actual keyword arguments. So if you want to extract these parameters, like what is being done before, when you extract out of keyword args, you're never getting the special parameters because the way it's defined when you set like equal to some value in your function signature, this is really a default argument. And then according to the standard, these get technically thrown in with the regular arguments and are resolved as such. So now this is extra work because regular arguments are just a tuple, so you don't have the names associated with the parameters. So it's still more work to find the special parameters. And so this is still a potentially problematic approach. So that's all I have. So thank you.